Back. This time we're going to talk about automatic model tuning. But before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. So, automatic model tuning in SageMaker. This is SageMaker's intelligent hyperparameter optimization service. Hyperparameters, learning rate, batch size, hidden layers, dropout. These are settings you configure before training. Wrong choices drastically reduce model quality, yet manual tuning wastes time and resources. AMT, which is automatic model tuning, applies intelligent search strategies to discover optimal settings efficiently. So how does this work? AMT integrates through SageMaker's infrastructure. It automatically spawns training jobs using defined hyperparameter ranges, works with built-in algorithms and custom containers, functions as a step in SageMaker pipelines, and powers optimization and autopilot behind the scenes. CloudWatch logs metrics from each tuning job work together. S3 stores model artifacts and logs. IAM controls access. SageMaker Studio provides GUI management and visualization. You use AMT when optimizing accuracy, F1 score, AUC, or custom metrics. Deep learning architectures particularly benefit from automated tuning. It's essential for cost-conscious hyperparameter experimentation at scale. So the costs, right? AMT charges no additional fees. You pay only for underlying compute resources. So EC2 training instances bill per second for each trial. S3 charges apply for model outputs and logs. CloudWatch stores tuning metrics and logs with associated costs. You can control expenses by setting maximum training job limits, enable early stopping to terminate underperforming trials, constraining hyperparameter ranges to avoid wasteful exploration, and choosing smaller instance types or spot instances where interruption is acceptable. So, how do you understand hyperparameters and the tuning strategies? So, GridSearch exhaustively tries all combinations of categorical values. It's deterministic, but computationally expensive. RandomSearch picks random combinations, easily parallelizes, but may miss optimal values. Bayesian optimization learns from previous results, building a probabilistic model of the objective function. It converges faster through smarter sampling, but limits parallelism. Hyperband combines early stopping with parallelism for fast results, working best with per-epoch metrics from deep learning models. Hyperband often delivers the best performance for neural networks that report metrics after each epoch. So, sequential versus parallel. AMT performs Bayesian optimization, learning as trials complete. Too many parallel jobs prevent effective learning. The algorithm can't incorporate results from running trials. So you run 1 to 2 jobs concurrently to balance performance against learning efficiency. This sequential bias means AMT differs fundamentally from embarrassingly parallel approaches like GridSearch. Let's see, WarmStart. Okay, so WarmStart leverages results from previous tuning jobs. The identical data and algorithm option assumes unchanged data and algorithms suitable for retrying failed jobs or refining ranges. Transfer learning allows different data, enabling adaptation from one dataset to another while preserving learned hyperparameter relationships. So what are best practices? Start with the 2 or 3 most sensitive hyperparameters rather than tuning everything simultaneously. Limit ranges using expert guidance or prior runs to avoid wasteful exploration. Use logarithmic scale for parameters like learning rate spanning orders of magnitude from 0.0001 to 0.1. Enable early stopping with the early stopping set to auto to terminate underperforming jobs automatically. Consider WarmStart to resume failed jobs or continue from previous tuning efforts. You would do this in the console, which we're not going to because you have to create a SageMaker notebook, and that is time consuming. So it would be similar to what we've done earlier, where you create that notebook, have your data in S3, create using the instance type, then you start setting your metrics regarding your algorithm hyperparameters, right? You choose that tuning strategy, you enable some limitations like the auto stop, and then you would launch, right? Configured with the WarmStart as an option. And then once executed, you can monitor this in SageMaker Studio or CloudWatch, and you can view each training job's hyperparameters and object metric values. And then you can identify top performing configurations as the trial is complete. The best model emerges from the systematic exploration rather than just guesswork. So how do you do this in production? AMT accelerates model optimization in ML ops pipelines, ensuring highest possible performance before deployment. It automates costly trial and error efforts. integrates with autopilot and pipelines, clarify and model monitor, and optimizes deep learning models across NLP, computer vision, and tabular predictions. So for the exam, when questions come up asking about automating hyperparameter optimization, reducing tuning costs, or choosing between search strategies, understanding automatic model tuning's capabilities and best practices will guide you to the correct answer. Well, that will be all for today. So thank you for joining us. Before we go, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. And have a good day.